Good morning. Now today I will start the new topic. This is the sliding contact bearing. What is sliding contact bearing? So first of all, I will just give you the description of this. Sliding contact bearing means when the relative motion between the journal and the bearing surface is sliding, right? So when the relative motion means when the journal is rotating there, and when there is a relative motion between the journal and in the bearing surface, the motion is sliding. So such type of bearings are called the sliding contact bearing, right? So what happens when there is a sliding motion? What happens there? So due to the sliding motion, what happens? So the friction is more. In this case, when the motion is sliding between the relative surfaces of the bearing and the journal, the friction is more. And when the friction is more, your heat transfer is more. Heat transfer is more. Your wear and tear is more, right? And torque transfer is less in this case. So what we will do to overcome these difficulties, to overcome this problem, what we do, lubricant plays a very important role here. So we need the lubrication here. So lubricant very important here. So to reduce the wear and tear, the losses due to frictions, and the heat for the heat generation. So this is about this sliding contact bearings. So what is your sliding contact bearing? That the relative motion between the bearing surface, you can say, I will write down that relative motion between the contact, relative motion between the contact surfaces of bearing and journal is relative motion between the contact surfaces of the bearing and journal is sliding, or you can say is in sliding motion. तो जब आपका जो कॉन्टैक्ट सर्फेसेस हैं आपके जो जर्नल के और वेयरिंग में जो उनका जो मोशन है, इफ देयर इज अ स्लाइडिंग मोशन, एंड व्हाट इज स्लाइडिंग मोशन? स्लाइडिंग मोशन इज लाइक दिस. सपोज यू आर हैविंग दिस, so it will slide like this. So when there is a sliding motion, so what happens? When the sliding motion between the two surfaces of the journal and bearing, what happens there? So first you can say due to this, what happens? So due to this, when there is a sliding motion, what happens there? Due to this, friction between the two contact surfaces of journal and bearing is or, right? तो जो फ्रिक्शन होगा इन दो सरफेसेस के बीच में क्या होगा? फ्रिक्शन आपका ज्यादा होगा पहला. तो जब आपका फ्रिक्शन ज्यादा होगा तो व्हाट हैपेंस? वेयर एंड टियर इज मोर. सो यू कैन से इन दिस केस wear and tear is more. Third, you can say wear and tear is more. Third one, what happens? The heat generation is very high, or you can say heat generation is more. and torque transfer you can say, or you can say there is a loss of torque. Torque transfer is less, or you can say there is a loss of torque. So these things will happen there when there is a sliding motion. So these things will happen here. So it means in order to reduce the effect of wear and tear, friction, heat generation, and the loss of torque, what we do here, there is a requirement of the lubricant. Here there is a requirement of the lubricant or the lubricating oil, and that lubricating oil will help us to reduce all these things here. So mainly you can say that the design of the sliding contact bearing or the journal bearing, that depends upon the lubrication. That depends upon the lubrication. So this is about, now you can say its application, where it will use. So its application is crankshaft of diesel or petrol engines. It is used in the crankshaft of the diesel and the petrol engines, pumps, gas turbines, steam turbines, and also in the heavy electrical motors, right? In the heavy electrical motor it is used. The motors which are having a very low capacity, that you can use the rolling contact bearing. What in the heavy electrical motor, the sliding contact bearing are used. So this is the application. So you can say application is where it is used. Applications. So you can say it is used in the crank shaft of engines, right? Pumps, heavy electrical motor, heavy electrical motor, gas and steam turbines, right? So I think you understood this thing. So what is the sliding contact bearing? You try to understand it. I will give you each and every detail of this chapter. Detailed everything I will explain here. So there is no need to read from anywhere, because I will not leave anything here. What is in this chapter is there. I will give you a full explanation and the detail of this. So you can say sliding contact bearing means what? Sliding contact bearing means when there is a sliding motion between the two contact surfaces of the bearing and the shaft. जब उनके बीच में जो मोशन होगा, that is a sliding motion. When there is a sliding motion, so due to this, what happens when the motion is sliding? What happens? The friction, there is a high production of the friction there, a high generation of the friction here, or you can say that friction is more in this case. So when the friction is more, what is there? Wear and tear is more, heat generation is more, and loss of torque is there. So in order to reduce the effect of these things, what we do, we just use the lubricating oil, or we use it is required the lubrication there, right? तो जहां पे जो lubrication part है, this is very important part, or you can say lubrication plays very important role here. So the design of your journal bearing, that depends upon the lubrication. What in case of rolling contact bearing, as I told you, suppose if anybody will ask you, if there is any theory questions there, and if anybody asks you what is the difference in the rolling contact bearing and the sliding contact bearing. So I will explain it also, that in rolling contact bearing what is there? The motion is, the relative motion is rolling, right? तो वहां पे जो बॉल रोलर्स हैं, बॉल बेयरिंग्स है या रोलर बेयरिंग्स है, उनके बीच में और जो शाफ्ट है उनके बीच में जो एक्शन होगा वो कौन सा होगा? दैट इज ए रोलिंग मोशन इज देयर. In case of this, there is a sliding motion, and when there is a rolling motion, you can say the friction is almost nil here. In case of rolling contact bearing, I will say friction is almost nil. When the friction is almost nil, because these things depends upon the friction. So when the friction is almost nil, then you can say that a wear and tear is almost negligible. Heat generation is almost negligible, and loss of torque is not there. So this is the difference in the rolling contact bearing, right? But in case of sliding contact bearing, as I told you, these are the things, and in case of rolling contact bearing, when these things will not happen there, friction is less, wear and tear is less, heat generation is less, so there is no need of lubrication there. So we don't require any lubricating material there, right? So there is no need of lubrication. But in case of the sliding contact bearing, you have seen so that these things are there because the motion is relative motion between the two contact surfaces, that is in journal and bearing. That motion is the sliding motion. And when there is a sliding motion, due to this what happens? These things are more. So in order to reduce the effect of these things, we need the lubrication here, right? So we need the lubrication here. So this is about the sliding contact bearing, and now I have also explained you what is the difference in the rolling contact bearing and the sliding contact bearing. Now the next one is, suppose I will give you the advantages and disadvantages of the rolling contact bearing and sliding contact bearing, right? थोड़ा सा इसके बारे में भी स्टडी कर लेते हैं, right? एडवांटेजेस और डिसएडवांटेजेस क्या होंगे इसके? So advantages oblique disadvantages of sliding contact bearing, right? So देखिए, first I will just give you the few advantages of the sliding contact bearing. तो सबसे पहला जो इसका advantages है sliding contact bearing का, it is having the more load carrying capacity. इसकी जो load carrying capacity होगी वो क्या होगी? ज़्यादा होगी. It is having a more load carrying capacity as the speed of the journal is go on increasing, as we are increasing the speed of the journal. So with the effect of the speed, as the speed increases, the load carrying capacity of the sliding contact bearing will increase. So first is that it is having the more load carrying capacity as compared to your rolling contact bearing. So you can say load carrying capacity is more. ठीक है? Load carrying capacity is more and it increases. So you can say it increases with respect it increases with respect to increase of the speed of journal। तो क्या है, जैसे जैसे हम जर्नल की स्पीड बढ़ती जाएगी, इसकी जो लोड कैरिंग कैपेसिटी है वो क्या होगी, ज्यादा होती जाएगी। सो दिस इज द एडवांटेज यू कैन से। इफ आई विल कंपेयर दिस विद द रोलर कॉन्टैक्ट बेयरिंग, तो रोलर कॉन्टैक्ट बेयरिंग का जो लोड कैरिंग कैपेसिटी है वो लो होगी, बिकॉज द कॉन्टैक्ट एरिया इज पॉइंट एरिया और द कॉन्टैक्ट एरिया इज ए लाइन एरिया, राइट। तो in case of this sliding contact bearing, its load carrying capacity is more because it increases with respect to the increase of the speed of the journal। Second you can say, second क्या है इसका, second इसका point है कि it can absorb the vibrations, shocks which produced during the operations of the machinery, right। तो ये क्या करेगा, ये जो शॉक्स या वाइब्रेशंस जो प्रोड्यूस होती हैं उसको इट इज हैविंग द डंपिंग कैरिंग कैपेसिटी, डैम्पिंग कैपेसिटी इसमें होगा। डैम्पिंग कैपेसिटी इट विल एक्ट एज ए कैपेसिटी ऑफ द डैम्पिंग कैपेसिटी, इट विल एक्ट लाइक दिस एंड इट विल एब्जॉर्ब द शॉक एंड द वाइब्रेशंस। यू कैन से दैट इट विल, सेकंड है, इट विल absorb the shocks, it will absorb the shock and vibrations due to damping capacity, ठीक है। तो सेकंड है इसका एडवांटेज कि ये अब्जॉर्ब करेगा इसको, शॉक्स को, वाइब्रेशंस को ये अब्जॉर्ब कर सकता है, ठीक है। सो दिस इज आल्सो वन ऑफ द एडवांटेज। नाउ द थर्ड वन व्हेन it is in the operating condition, suppose journal bearing, when it is in the running condition you can say, or the hydrodynamic bearing in case of hydrostatic bearing, when it is in the running conditions, what happens, there is a thick formation of the lubricant or lubricating oil between the bearing surface and the journal surface, right। So there is a thick formation of lubrication there when it is running in the full operating speed। Initially no doubt, initially there is metal to metal contact for 5 seconds, 10 seconds there is metal to metal contact। reason is that जब तक ये अपनी स्पीड को फुल अटेन नहीं कर लेता, जो उसकी ऑपरेटिंग स्पीड है, जो बेयरिंग की ऑपरेटिंग स्पीड है, जब तक ये अटेन नहीं कर लेता, तो ड्यूरिंग दैट पीरियड यू कैन से 5 सेकंड, 10 सेकंड, ड्यूरिंग दैट मीटर देयर इज ए मेटल टू मेटल कॉन्टैक्ट देयर। व्हाट, after gaining the full operative speed, what happens, when it will gain the full operative speed, the lubricant oil will fill between the gap of the bearing and the journal surface। So there is a lubricating oil there, so there is no metal to metal contact in that case। So what happens, that the operation of this sliding contact bearing is noiseless, you can say, it causes the noiseless operation। So this is also one of the advantage, that in mostly in case of hydrostatic bearing, in hydrodynamic bearing or in journal bearing, there is no metal to metal contact when it is running in the full operative speed। So when it is running into a full operative speed, there is no metal to metal contact, so it means there is no noise at all, because it is running in between the thick film of the lubrication there। So that operation is your this noiseless a free of noiseless operation there, free of noise operation there, or you can say it causes the noiseless operation. So third, you can say it causes the noiseless, it causes the noiseless operation, right? So this is also one of the advantages. Now next one is that sometimes some bearings are designed like this, they are having the split type of structure, means ये split हो जाती हैं, this is split type of structure. Some bearings are designed like this, so that will facilitate these bearings according to the shape of the system, right? So you can say that in the crankshaft of the engine, these bearings can be applied there, right? So ये जो इनका जो स्ट्रक्चर है, स्प्लिट टाइप स्ट्रक्चर है, उससे ये होता है कि इनको बेयरिंग्स को आप एक प्रॉपर तरीके से एज पर द design of the other things where you have to apply the bearing, you can adjust that. So bearing will facilitate there. So this is the fourth point, that it is having a split type structure and it can be used where the other things or other bearings are very difficult to use there. We can use there. So this is the fourth one. One more I will give you the advantage of this. Its service life is not fixed, as in case of rolling contact bearing, the service life is fixed, that is 10 to power 10 revolution per minute, and also depends upon the speeds, so depends upon the revolutions. What here, the service life is not fixed, right? Iski service life fixed nahi hai, and moreover it doesn't depend upon the speed. So you can say that its service life is not fixed. Fixed duration, you can say. Its service life is not fixed duration and doesn't depend upon the speed, and does not depend upon the speed. ठीक है. So I think ये मैंने आपको कुछ इसके advantages बताए and I think you have understood it. तो इसके क्या advantages दिए मैंने सबसे जो मेन इंपॉर्टेंट एडवांटेज इसका है कि इट्स लोड कैरिंग कैपेसिटी स्मॉल. तो जैसे जैसे जर्नल को जो है इट विल गो ऑन कैचिंग द स्पीड, जैसे जैसे उसकी स्पीड बढ़ती जाएगी इसकी लोड कैरिंग कैपेसिटी जो है वो बढ़ती जाएगी, राइट. सो यू कैन से इट इंक्रीजेस, दैट इट इंक्रीजेस मींस लोड कैरिंग कैपेसिटी. लोड कैरिंग कैपेसिटी ऑफ दिस पर्टिकुलर बेयरिंग increases with respect to the increase of the speed of the journal, right? This is the first advantage. Second one, you can say that it will absorb shocks and vibrations due to damping characteristics. इसका एक damping characteristic है, it will act like a damping characteristics. तो damping क्या होता है कि shocks और vibrations को absorb करना, उनको dampness देना. As you have read in the vibrations, if you will study the vibration chapter, so there is a single free system also there and damping system is also there. Damping system means there is a provision of the damper there, and that damper what will do, that damper will absorb the shocks and vibrations. So you can say that in case of this sliding contact bearing, it will also act like a damper and it will absorb the shocks and vibrations due to the operation of the engines or the machinery, you can say, right. तो ये उसको जो इसका vibrations होगा, जो इसके shocks होंगे, ये इसको absorb करेगा, ये इसको damping effect इसका होगा, so that कि मशीनरी विल नॉट बी डैमेजेस, ठीक है, तो ये उसको एब्जॉर्ब करेगा। थर्ड यू कैन से इसका ऑपरेशन जो है नॉइजलेस होता है, तो इसका ऑपरेशन जो नॉइजलेस होता है उसको मैंने आपको एक्सप्लेन किया था कि किस तरीके से होगा कि इन मोस्ट ऑफ द बेयरिंग यू कैन से इन हाइड्रोस्टैटिक बेयरिंग, इन हाइड्रोडायनामिक बेयरिंग और इन जर्नल बेयरिंग, lubrication plays a very important role here in case of sliding contact bearing, right? So you can say when the bearing is in the full running operation, so the gap between the journal and bearing that is filled with the thick film lubrication oil. So there is no metal to metal contact here, means there is no metal to metal contact here. So when there is no metal to metal contact there, so it means there is no rubbing of the metals, there is no noise at all, because the bearing and journal both they are rotating in between the thick film, not both they are rotating, journal is rotating and the relative, you can say relative surfaces, in between the relative surfaces there is a thick film lubrication and journal is rotating in that. So there is no metal to metal contact of the journal with the bearing. So the operation you can say that operation, during that operation, that is a noiseless operation. It causes a noiseless operation. I think you have understood it well. Now the next one is, I just forgotten to write down here. तो मैंने कहा था कि इसका split type structure होता है, some bearings are designed like a split type structure, so that bearing will facilitate as per the design of the other journals and other things. तो ये split type होने से क्या होगा कि इसको आप एक फैसिलिटी अवेलेबल हो जाएगी कि आप इसको एक प्रॉपर तरीके से bearing को एडजस्ट कर सकते हैं as per the design of the shaft and other things. So you can say this is the fourth one, and the next one I have given you, its service life is not, its service life is not fixed, ठीक है, इसका जो सर्विस लाइफ होगा फिक्स नहीं होगा। जैसे इन केस ऑफ रोलिंग कॉन्टैक्ट बेयरिंग क्या है, जो उनकी सर्विस लाइफ है वो फिक्स है, उसमें उन्होंने लाइफ बताई है कि इसकी कितनी लाइफ है, 10⁻⁶, 10⁻⁹, एवरेज लाइफ क्या है, रिलायबिलिटी क्या है एंड लाइफ क्या है, राइट। उसकी एक जब हम डिज़ाइन करते हैं, मैन्युफैक्चर करते हैं, तो वो नंबर ऑफ रेवोल्यूशंस के ऊपर डिपेंड करता है कि कितने नंबर ऑफ रेवोल्यूशन तक ये बेयरिंग जो है वो ये ऑपरेट कर सकती है। सो यू कैन से दैट इन केस ऑफ रोलिंग कॉन्टैक्ट बेयरिंग द लाइफ इज फिक्स्ड, बट इन केस ऑफ दिस स्लाइडिंग कॉन्टैक्ट बेयरिंग द लाइफ इज नॉट फिक्स्ड, और ना ही ये स्पीड के ऊपर डिपेंड करती है, डजंट डिपेंड अपॉन द स्पीड, राइट। So these are some advantages of this sliding contact bearing. Now I will give few disadvantages also there. So some few disadvantages are also there. So तो डिसएडवांटेज इसके क्या होंगे? सो सबसे पहला जो इसका डिसएडवांटेज है, जैसे मैंने आपको पहले बताया था कि इनिशियली व्हेन इट इज नॉट इन द ऑपरेटिंग स्पीड, जब भी हम किसी इंजन को स्टार्ट करेंगे, राइट, तो जो जर्नल का जो बेयरिंग का हमने उसका बताया है कि इट कैन सस्टेन अप टू 1000 RPM, राइट। तो स्टार्टिंग में क्या होगा, दैट विल नॉट इन द ऑपरेटिंग स्पीड, इट विल टेक फ्यू सेकेंड्स, यू कैन से 5, 7, 10, 15 सेकेंड्स टू रीच एट दिस ऑपरेटिंग स्पीड। तो जो आपका इनिशियल आपका वो जो टाइम होगा, आर यू शट ऑफ द इंजन, जब इंजन को बंद करेंगे तो वो जो टाइम होगा और जब आप इंजन को स्टार्ट करते हैं वो जो फ्यू सेकंड्स होंगे उसके दौरान क्या होगा, देयर इज ए मेटल टू मेटल कांटेक्ट बिटवीन द बेयरिंग एंड द शाफ्ट. देयर इज ए मेटल टू मेटल कांटेक्ट बिटवीन द बेयरिंग एंड द शाफ्ट. और यू कैन से इनिशियली क्या होगा, फ्रिक्शन प्रोड्यूस वहां पे ज्यादा होगी, राइट. जब इनिशियली जो टाइम होगा द फ्रिक्शन इज मोर एट दैट टाइम. जब फ्रिक्शन मोर होगा तो क्या होगा, जो आपका टार्क है इनिशियल स्टेज के ऊपर टार्क का लॉस जो है ज्यादा होगा. सो दिस इज द फर्स्ट डिसएडवांटेज देयर, राइट. सो यू कैन से इनिशियली starting friction, or you can say starting friction is more, ठीक है ना. And we require more torque there, right. So initial torque is more there, ठीक है. उसमें अगर फ्रिक्शन ज्यादा है तो उसको रन करने के लिए हमें टार्क जो है ज्यादा चाहिए. सो यू कैन से दैट इनिशियल टार्क इज मोर, राइट. तो दिस इज यू कैन से दिस इज योर फर्स्ट डिसएडवांटेज. इसको दोबारा एक्सप्लेन करेंगे हम कि क्या डिसएडवांटेज है आपका, कि जब हम इंजन को टर्न ऑन करते हैं, राइट, and when it will start rotating, right, when the shaft will start rotating, definitely it will take some time to reach at the maximum operative speed. Suppose it is designed at this particular bearing is designed at 1000 rpm, right. So it will take some time, first 0, 10, 20, 50, 100, 200, 400, 500, like this. So maybe that time is very short, but it will take some time or few seconds to reach at this operative or running condition. So what happens during that period, what happens there is a metal to metal contact between the journal and the bearing, and when there is a metal to metal contact there, so it means the friction is more, or the initial friction is more, or you can say the starting friction is more, which is not in the case of rolling contact bearing. Rolling contact bearing में फ्रिक्शन, इनिशियल फ्रिक्शन जो है बिल्कुल ऑलमोस्ट नेग्लिजिबल होता है. What in case of sliding contact bearing, the friction is more because there is a sliding motion there, right, and this journal is not in the full operative speed. So during that there is a metal to metal contact, and when there is a metal to metal contact, what happens, friction is more, and when there is a friction more, it means that initially we require more torque. तो initial जो होगा starting torque जो हमें ज्यादा अप्लाई करना पड़ेगा. This is the first point, right. Now the next you can say next इसमें जो शाफ्ट का एक्सिस है और जो बेयरिंग का एक्सिस होगा, दे आर नॉट सेंट्रिक हियर. So they are eccentric, you can say, not eccentric means they are eccentric to each other, right. So due to this eccentricity, what happens there, they are not lying on the one plane only, means they are eccentric to each other. So if you want to maintain the precise, you can say, alignment of bearing and shaft, so it is not very difficult to maintain the precise alignment there. तो आप कह सकते हैं कि जो इसकी अलाइनमेंट है, क्योंकि जो शाफ्ट का एक्सिस है और जो बेयरिंग का एक्सिस होगा, that is eccentric, and due to this eccentricity what happens here, that these will not, जो अलाइनमेंट आपका है bearing का and shaft का, that is not perfect alignment there. There is always a misalignment there. So there is not perfect alignment there. So this is the second, you can say, disadvantages of this. Sorry. So, sorry, actually it is fallen down here, and so I took some time. तो ये मैंने बताया था ड्यू टू एसेंट्रिसिटी, क्योंकि ये जो दो शाफ्ट हैं, इसके शाफ्ट ऑफ एक्सिस ऑफ द शाफ्ट एंड द shaft of your this bearing, they are not eccentric to each other, and due to this what happens, there is a not precise alignment in case of shaft and bearing there, right? This is the third one, you can say. इसमें एक और है, क्योंकि जहां पे जब आप lubrications इस्तेमाल करेंगे तो क्या होगा, lubrications के लिए we require certain accessories there, right? We require certain accessories there because we require some, you can say, pump, we require pump, lubricating oil, sump we also require, and pump line is also required. So these are the additional accessories which we require in case of sliding contact bearing, and these accessories will increase the initial cost of the bearing, right? So these accessories will increase the initial cost of bearing. So you can say that in case of some bearings in sliding contact bearing, initial cost is more than the rolling contact bearing. So this is also one of the disadvantages. मैंने eccentricity वाला तो आपको बता दिया कि there is no perfect alignment, there is no perfect alignment of the shaft and axis there, right? So third one is that due to this additional accessories which we require in case of the lubricating system of the journal bearing, hydrostatic bearing, so that system, you can say, that will increase the cost more. So when the initial cost is more, so you can say that its maintenance cost is also more, because we have to replace the lubricating oil periodically at every interval of the time. एक रेगुलर इंटरवल टाइम के ऊपर हमें क्या करना पड़ेगा, lubricating oil को चेंज करना पड़ेगा, we have to replace it, so that will also add the cost. So you can say that its maintenance cost is also high, initial cost is high. As I told you, initial cost कैसे high होगी, because in some bearing we require the accessories for the lubrication system, and that accessory may be the sump tank, that is the pipe, pump line, and the lubricating oil. Definitely that will increase the cost of your this bearing. This is the initial cost is high, and if we will go on the maintenance, and discuss that, so its maintenance cost is also high. Reason is that we have to regularly replace the lubricating oil time to time, or you can say at every interval of time you have to replace the time. So definitely that will add the cost more there, that will increase the cost here. So these are few some disadvantages, you can say. One more is there कि इसका जो manufacture है, it is not a standardization type of manufacture there, as in case of rolling contact bearing, उसका एक standardized manufacture है. तो ये जो bearing आपको sliding contact bearings जो है, ये आपको standardize इसका manufacture नहीं होगा. इसलिए जब आपको ये बेयरिंग रिप्लेस करनी होगी तो ये जो मैन्युफैक्चरर का जो कैटलॉग है उसमें आपको सेम टाइप की बेयरिंग मिलना मुश्किल हो जाता है। बात समझ आई आपको? सो यू कैन से बट आई एम टेलिंग यू दैट इट्स इज नॉट द स्टैंडर्डाइजेशन प्रोडक्शन, इसका स्टैंडर्डाइज सिस्टम नहीं है। So if you want to replace this, suppose if your this bearing is damaged and you have to replace this, it is not sure that you will get the same type of bearing, or you can say that the replacement may be different, somewhat different there. So these are the few disadvantages which I have told you. I think now I have explained each and everything regarding the sliding contact bearing. Sliding contact bearing क्या है, उसमें मोशन कौन सा है, इसके एडवांटेजेस क्या है, इसके डिसएडवांटेजेस क्या है, इसका और रोलिंग कॉन्टैक्ट बेयरिंग का आपस में डिफरेंस क्या है. सो दिस इज ऑल अबाउट योर दिस यू कैन से थ्योरेटिकल पार्ट ऑफ दिस स्लाइडिंग कॉन्टैक्ट बेयरिंग. एंड इफ एनी क्वेश्चन, if any theoretical question in GATE or you can say your CSE examination will come, so I think I have completely explained you each and everything regarding your the sliding contact bearing. Now the next one we will come to the types of bearing, right? So first understand, mainly the sliding contact bearings are divided in two parts, right? जो स्लाइडिंग कॉन्टैक्ट बेयरिंग है इसको ध्यान से सुनिए आप. जो स्लाइडिंग कॉन्टैक्ट बेयरिंग्स है मेनली ये दो पार्ट्स में इनको डिवाइड किया गया है. वन पार्ट यू कैन से रेडियल कॉन्टैक्ट बेयरिंग एंड द सेकंड पार्ट यू कैन से थ्रस्ट बेयरिंग. ठीक है, ये इसको बनाते हैं जहां पे देखिए स्लाइडिंग कॉन्टैक्ट बेयरिंग, दिस इज डिवाइडेड इनटू पार्ट्स. रेडियल कॉन्टैक्ट बेयरिंग, right, and the second part is your thrust bearing, right. अब ये जो रेडियल बेयरिंग्स है, रेडियल कॉन्टैक्ट बेयरिंग है, ये भी आपका दो पार्ट में डिवाइड है. रेडियल कॉन्टैक्ट बेयरिंग और यू कैन से जर्नल बेयरिंग्स. तो इनको हम जर्नल बेयरिंग भी बोलते हैं, रेडियल कॉन्टैक्ट बेयरिंग और जर्नल बेयरिंग. अब ये जर्नल बेयरिंग जो है दैट इज डिवाइडेड इन टू पार्ट, फुल जर्नल bearing, and second one is partial journal bearing. ठीक है, फुल जर्नल बेयरिंग एंड पार्शियल जर्नल बेयरिंग. Now thrust bearing is divided into parts, that is pivot, P-I-V-O-T, pivot bearings and collar bearing. अब ये pivot bearing जो है this is also divided into parts. पाइवट बेयरिंग्स भी दो पार्ट्स में डिवाइड है. यू कैन से फुट स्टेप बेयरिंग, bearing and conical bearing, right? Now you come to this collar bearing, that is also divided in two parts. Collar bearing, that is also divided in two parts, that is single collar bearing and multicollar. Single collar bearing and multicollar bearing, right? So these are the description of your this bearing. So sliding contact bearings, they are mainly divided in two parts. जो major parts हैं इसके, ये उन दो parts में divide होता है, radial contact bearings और thrust bearing, right? तो radial contact bearing क्या है? That I will take one by one here, right? So in the radial contact bearing, you can say the direction of the load is radial, or you can say the radial load is acting on that, right? Radial load is acting like this. Suppose करो So this is your radial load F1. This is acting perpendicular. This is acting vertical or perpendicular to the axis of the rotation here. ये आपका radial load है and that is at any direction. किसी भी डायरेक्शन के ऊपर जब रेडियल लोड जहां पे एक्ट करेगा तो दैट इज ए परपेंडिकुलर टू द एक्सिस ऑफ रोटेशन हियर. सो दिस इज योर दिस रेडियल कॉन्टैक्ट वेयरिंग, or you can say the radial contact bearing is also said as the journal bearing. रेडियल कॉन्टैक्ट बेयरिंग को हम जर्नल बेयरिंग भी कहते हैं. अब देखिए व्हाट इज योर दिस जर्नल बेयरिंग. इन दिस योर द जर्नल बेयरिंग, व्हाट इज जर्नल बेयरिंग? जो शाफ्ट है आपका, शाफ्ट के सरफेस के ऊपर एक स्लीव जो है, उस सरफेस के ऊपर उसको स्लीव जो होती है, इट इज जस्ट लाइक ए स्लीव देयर इन ओवर द सरफेस ऑफ द शाफ्ट. So that sleeve will act as the bearing, right? On the surface of the shaft there is a sleeve. तो in case of this journal bearing, ये आपका शाफ्ट है तो इसके ऊपर इस तरीके से इसका स्लीव होगा over the surface of the shaft. Sleeve is over the surface of the shaft there. So this is your journal bearing, right? But in case of journal bearing, for what I told you, first thing is that the relative motion between the journal and the bearing, that is a sliding motion, right? So जो आपका स्लाइडिंग मोशन होगा इसमें, जर्नल बेयरिंग के केस में जो आपका स्लाइडिंग मोशन होगा, वो आपका स्लाइडिंग मोशन क्या होगा? along the circumference of the circle. ये आपका बिकॉज योर शाफ्ट इज जस्ट ए राउंड लाइक दिस, शाफ्ट आपका राउंड है और बेयरिंग जो है इसके ऊपर जो स्लीव है दैट इज राउंड है। जो इनके बीच में मोशन होगा, जब ये शाफ्ट जो रोटेट करेगा तो इनके बीच में जो मोशन होगा ये इस तरीके से ये जो मोशन होगा, ये मोशन आपका क्या होगा, along the circumference of the सर्कल, जो सर्कल का सर्कमफ्रेंस है उसके ऊपर इसका मोशन होगा, राइट। और दूसरा व्हाट इज जर्नल, हमने ये जर्नल तो बोला, व्हाट इज जर्नल, जर्नल वेयरिंग। सो व्हाट इज जर्नल, दिस पार्ट ऑफ द शाफ्ट, द पार्ट ऑफ द शाफ्ट which is inside the bearing, the part of the shaft which is inside the bearing, that part is called journal। बेसिकली क्या होता है, होता शाफ्ट ही है, दैट इज शाफ्ट हियर, लेकिन जो पार्ट आपका बेयरिंग के बीच में, सपोज दिस इज माय बेयरिंग एंड इफ दिस पार्ट यू कैन से दिस पार्ट इज इनसाइड द बेयरिंग, if this part is inside the bearing, so you can say this part is called journal। I think you understood it well। तो जहां पे 2-3 फैक्टर्स मैंने बताया कि व्हाट इज जर्नल बेयरिंग। जर्नल बेयरिंग क्या है, एक स्लीव है जो शाफ्ट के ऊपर, स्लीव को शाफ्ट के ऊपर इस तरीके से चढ़ाया गया है, ठीक है। वो जो स्लीव है ओवर द शाफ्ट, दैट स्लीव विल एक्ट एज ए बेयरिंग। और जो शाफ्ट का पार्ट जो उसके बेयरिंग के बीच में है, दैट पार्ट इज कॉल्ड द जर्नल, राइट, दैट पार्ट इज कॉल्ड द जर्नल। सो जर्नल मीन्स व्हाट, द पार्ट विच इज इनसाइड द बेयरिंग सरफेस, दैट पार्ट इज कॉल्ड द जर्नल। नेक्स्ट वन इज द स्लाइडिंग मोशन इज व्हाट, what type of sliding motion is there? So you can say that sliding motion is along the circumference of the circle in case of journal bearing, or on the arc of the circle. Why I have taken the arc of the circle? Why I said this arc of the circle? Because in case of this your partial journal bearing, in case of your this partial journal bearing, this journal is not protected throughout 360 degree, or you can say it is not protected thoroughly by the bearing. So some part of the journal is protected, or you can say 120 degree of about 120 degree of the journal is protected from the bearing, by the bearing, and that if there is a 120 degree, if there is a protection, you can say this is a half part, this is a bearing and this is the half part which is protected. So you can say either the sliding motion is along the circumference of the circle or along the arc of the circle, right? And the, you can say, load which is acting on this is acting in the radial direction, this is acting like this, this is acting perpendicular to the axis of rotation of the shaft, or it is acting like this, right? And this is at any direction, ठीक है ना, ये किसी भी डायरेक्शन से, ये इधर से भी ये एक्ट कर सकता है परपेंडिकुलर, इधर से भी करेगा, इससे भी करेगा, इससे भी करेगा, इस तरीके से भी करेगा। सो दिस इज एक्टिंग in all directions. So this is about your radial contact bearing. I think you have understood. Now journal bearing, मैंने आपको बताया what is journal. Journal is a part of the shaft which is inside the bearing, right? How it, what type of motion is there? There is a sliding motion between the bearing and the shaft surfaces, and its motion is along the circumference or the arc of the circle there. And the third one is that radial load is acting perpendicularly. You can say there is a radial load acting, and it acts at each and every side of the each and every direction of the journal. ठीक है, तो जो किसी भी डायरेक्शन से इसके ऊपर एक्ट कर सकता है। तो जहां तक आई थिंक एवरीथिंग इज क्लियर टू यू। अब नाउ जर्नल बेयरिंग is again classified as full journal bearing and partial journal bearing. जैसे इसका नाम है full journal bearing. So full journal bearing means first part is, which I have already told you while explaining this, the definition of the journal bearing, that shaft is protected at 360 degree. कि ये जो शाफ्ट होगा ये फुली प्रोटेक्टेड है 360 डिग्री. और यू कैन से जो बेयरिंग सरफेस है, बेयरिंग है इसका, वो शाफ्ट के ऊपर पूरा 360 डिग्री इस तरीके से बेयरिंग सरफेस होगा. तो शाफ्ट इज प्रोटेक्टेड है 360 डिग्री. ये किस लिए होगा? जब आपका रेडियल लोड जो है दैट एक्ट्स इन ऑल डायरेक्शन. when the radial load is acting in all the directions, to give the support to the radial loads in all the direction, we need the full journal bearing. We need full journal bearing. So in case of full journal bearing, you can say its protection is 360 degree, right? Or you can say that that shaft is protected all around its circumference by the bearing, and the radial load which is acting on this, and the radial load which is acting on this, that is acting at every directions. ठीक है जी, आपका हो गया full journal bearing. Now अब partial journal bearing means what? As its name, partial journal. Partial means some part of the journal. Partial means some part of the journal is protected. So that part you can say 120 degree. There is a protection of 120 degrees there. So you can say it is just like this. Suppose this is your shaft, right? Or you can say this is your shaft, and this is your bearing. It is almost like this. ठीक है ना, ये पार्ट है, ये जर्नल है आपका. तो here you can say, suppose this is your shaft, right? This is your shaft. This is your shaft, right? So some part of the shaft is protected by the bearing. You can say almost 120 degree part of this that is protected by this. And in this case, only you can say radial load in one direction can act. In this case, only the radial load in one direction will act, because there is only the protection toward this side. There is no protection this side, there is no protection this side. So this is the partial protection, you can say. So this type of journal bearing is called the partial journal bearing. अब now the difference is कि जे बेयरिंग हमें पार्शियल जर्नल बेयरिंग जो है ये किस लिए, वाई वी हैव फ्रेम्ड दिस पार्शियल जर्नल बेयरिंग. जस्ट ट्राई टू अंडरस्टैंड. इन केस ऑफ एक्सिस, in case of axle, what is there? In case of axle is rotating, and the axle means it has to support the weight of the wheel or weight of the body. एक्सल का क्या काम होता है? वेट को सपोर्ट करना. या जो व्हील है आपका, अगर व्हीकल है, इंजन है, कोई भी है, तो उसको आपने सपोर्ट करना, ये एक्सल का है. In case of axle, there is no transfer of power. एक्सेल क्या करता है? एक्सेल पावर को ट्रांसफर नहीं करता है, टॉर्क को ट्रांसफर नहीं करेगा। एक्सेल का जो काम होगा वो सिर्फ जो व्हील का या व्हीकल का जो भी लोड है उसको सपोर्ट करना है। तो ऐसे केस में क्या होगा, जो रेडियल लोड एक्ट करेगा, दिस इज एक्टिंग लाइक दिस। जो इसका रेडियल लोड होगा, इट इज एक्टिंग लाइक दिस, राइट, सिर्फ ओनली इन वन डायरेक्शन। इट्स रेडियल लोड इज एक्टिंग ओनली इन वन डायरेक्शन। So in this case what happens, we need the partial journal bearing, right? But in case of shaft, the same thing will not be there, because the shaft is rotating, and when it is rotating, shaft is transferring the torque. shaft का क्या काम होता है? One part of the engine to other part, it will transfer the torque. And when it will transfer the torque, it means that the forces, or you can say the direction of the load, is not only in one direction, that is at every direction, that is from every side or every direction, the direction of the force, because the shaft is transferring the torque, and the direction of the radial load is, you can say 360 degree in every direction. So in this case we require the full journal bearing. And in case of your this axle, because axle simply it has to support the load of the vehicle or the load of the wheel, so only the radial force which is acting only directly in the downward direction, in the vertical direction, only in one direction. So in this case we need the partial journal bearing. I think you understood. You also understood the difference of the axle and shaft, because axle जो होता है, it simply support the load, इसलिए जो force होगी इसके ऊपर, जो load होगा, that acts only in one direction. What in case of this journal bearing, in case of this shaft, what happens? Shaft is rotating, and when the shaft is rotating, it is transferring the torque from one shaft to another shaft, or one part of the engine to the other part of the engine. So when it is transferring the torque, it means that the direction of the load is not only in one direction, but it is throughout its periphery, you can say 360 degree direction. At 360 degree direction, the radial forces are acting on the shaft here. So in this case we need the full protection there. हमें क्या चाहिए? Complete protection चाहिए इसकी shaft के round about. We need the full protection there. So giving the full protection, हमें कौन सा bearing use करना पड़ेगा? We use the full journal bearing. But in case of this axle, as I told you, that there is only one direction of the load, it is only simply supporting the load of the wheel of, you can say. So that in that case we use the partial contact bearing. I think you have understood it well. ठीक है, तो partial contact bearing क्या है, full journal bearing क्या है? तो ये part, this part we have done, right? Now we will come to the thrust bearing. Understand what is thrust bearing? Thrust bearing के केस में आपका क्या है? ये एक्शियल लोड को सपोर्ट करेगा। थ्रस्ट बेयरिंग क्या है? ये एक्शियल लोड को सपोर्ट करेगा। सपोज इन केस ऑफ थ्रस्ट बेयरिंग यू कैन से द shaft is vertical. Mostly the shafts are horizontal position, but this bearing that will support the shaft of vertical direction. Means जब shaft आपकी vertical direction में होगी तो this is your axis, right? So this is your axis, and load is acting on the axis of the shaft, or you can say the load is acting along the axis of the shaft. So such type of bearings are called the thrust bearings, right? You understand? So such type of bearings such type of the bearings are called the thrust bearing when the load is acting along the axis of the shaft, right? अब ये जो thrust bearing है, this is also divided in two parts. One part is called the pivot bearing and the second part is called the collar bearing. Now we will take what is this pivot bearing. Just see here. I will rub it because I need the space, so I will rub it now. Pivot bearing क्या है? It is just like this, right? It is just like this. So पहला तो ये है कि पाइवट बेयरिंग क्या है. Pivot bearing is also called the footstep bearing. This is called the footstep bearing. तो footstep bearing में क्या होगा? The shaft is vertical, that is supported on the bearing. इसका जो first point क्या है कि the base of the shaft that is in direct contact with the base of the bearing. Or you can say the shaft is in direct contact with the bearing, right? It is a flat case, flat, ठीक है ना? ये आपका क्या है? ये flat है, right? तो this is also called the flat pivot bearing or the footstep bearing. तो ये आपका direct contact किसके साथ है? Bearing का surface जो इसके साथ direct contact है. So this is the oil which is going inside and this is the lubrication film there. But it is in direct contact of this, and in this case the load, this is acting along the direction of the axis, right? Mostly in case of, as I told you, that in case of the thrust bearing, this shaft is perpendicular, our shaft is in vertical position. Otherwise mostly the shaft is in the horizontal position, but where the shaft is in the vertical position we use the footstep type of bearing there, right? So footstep of bearing का सबसे जो important point, and one point which you have to remember it, that the surface of the shaft is in direct contact with the surface of the bearing here, and the load is acting in the load is acting along the axis of the shaft, right? So this is also called the footstep bearing. Now conical bearing क्या होगा? A conical bearing means क्या है? When the, you can say, कॉनिकल बेयरिंग आपका आ गया जब इसका शाफ्ट का जो बेस है, इट इज जस्ट लाइक ए कॉनिकल टाइप. द बेस ऑफ द शाफ्ट इज just like a conical type, and it is in direct contact with the bearing. सिर्फ इसमें डिफरेंस क्या है कि जो इसका बेस है दैट इज कॉनिकल टाइप का है, इस तरीके से है, एंड दिस इज इन डायरेक्ट कॉन्टैक्ट दैट, रेस्ट एवरीथिंग इज सेम. द लोड इज एक्टिंग अलोंग द एक्सिस ऑफ द शाफ्ट, राइट. लोड इज एक्टिंग अलोंग द एक्सिस ऑफ द शाफ्ट. So this is your footstep bearing and this is your conical bearing. Now we will come to this single collar bearing. What is collar bearing? In case of this pivot bearing, in case of this pivot bearing or the footstep bearing or conical bearing, what you have seen that the face of this, the shaft is in direct contact with the bearing surface, right? Whether it is flat, whether it is conical. What in case of collar bearing, what is there? That the base of the shaft and the base of the bearing is not in direct contact there. वो डायरेक्ट कांटेक्ट में नहीं होगा, तो उसके लिए क्या करना पड़ेगा? ये जो आपका बेयरिंग है, ये जो आपका रॉड है, इसका शाफ्ट है, इसके ऊपर आप एक कॉलर, इस तरीके से, कॉलर इज जस्ट लाइक ए राउंड सर्कुलर टाइप ऑफ दिस, यू कैन से, और मैं जहां से इसका बनाऊंगा, सपोज दिस इज योर शाफ्ट, तो सामने से हमें इस तरीके से दिखाई देगा, दिस इज योर कॉलर, ठीक है ना. तो जस्ट आई सिंपली ट्राई टू मेक यू अंडरस्टैंड. तो ये क्या है कि इस केस में जो बेयरिंग सरफेस है और शाफ्ट का सरफेस है दैट इज नॉट इन डायरेक्ट कांटेक्ट टू ईच अदर. इस केस में क्या होगा कि ये जो शाफ्ट है आपका, इसके ऊपर हम एक कॉलर लगाएंगे. कॉलर क्या है? इट इज जस्ट लाइक ए सर्कुलर पीस, राउंड टाइप ऑफ पीस अराउंड द शाफ्ट, इस तरीके से, और दैट विल रेस्ट ऑन द बेयरिंग. जो शाफ्ट का बेस है दैट विल नॉट इन कांटेक्ट विद द बेयरिंग, तो बेयरिंग के कांटेक्ट में क्या रहेगा? कॉलर. कॉलर विल रेस्ट ऑन द बेयरिंग एंड द surface of the shaft is not in direct contact with this. So this type of bearing you can say collar bearing. समझ आया आपको? कॉलर बेयरिंग क्या है? कॉलर बेयरिंग में ये है कि सबसे पहला पॉइंट जो आपको अंडरस्टैंड करने की आपने कोशिश करनी है कि कॉलर बेयरिंग में देयर इज नो डायरेक्ट कांटेक्ट बिटवीन द सरफेस, बिटवीन द बेस ऑफ द शाफ्ट एंड द बेयरिंग. तो वो जो डायरेक्ट कांटेक्ट होगा वो कहां जाएगा? वो जो डायरेक्ट कांटेक्ट होगा दैट इज सपोर्टेड बाय द कॉलर. ये जो कॉलर इसके राउंड अबाउट हम शाफ्ट में लगाएंगे दैट इज सपोर्टेड ऑन द बेयरिंग and the load of the shaft that is supported by the collar that is not in direct contact with the bearing, right? So this is, you can say, collar bearing. Now the collar bearing is also divided in two parts, that is single collar bearing and the multi collar bearing. So single collar bearing means when we use only one collar on the shaft to support the load of the shaft. जब हम सिर्फ एक कॉलर शाफ्ट के ऊपर लगाएंगे तो ये जो आपका कॉलर है दैट विल सपोर्ट द लोड ऑफ दिस शाफ्ट बिकॉज द शाफ्ट इज नॉट इन डायरेक्ट कांटेक्ट विद दिस. द कॉलर इज इन कांटेक्ट विद द bearing, right? So when there is only single color here, you can say this is single color wearing. And when we use more than one color, means two colors, three colors like this, when we will use more than 2-3 colors, suppose this is your shaft, and when we will use this one color, सेकेंड, तो इस तरीके से जब हम एक से ज्यादा कॉलर हम इस्तेमाल करेंगे टू सपोर्ट द लोड ऑफ द शाफ्ट एंड दीज कॉलर्स आर रेस्टिंग ऑन द वेयरिंग, शाफ्ट इज नॉट इन डायरेक्ट कॉन्टेक्ट विद द वेयरिंग, तो जब हम एक से ज्यादा कॉलर का इस्तेमाल करेंगे तो उस टाइप की जो बेयरिंग होगी उसको हम कहेंगे मल्टी कॉलर बेयरिंग। अब इसमें एक जो इंपॉर्टेंट पॉइंट अंडरस्टैंड करने वाला है वो क्या है, व्हाट इज द इंपॉर्टेंट पॉइंट हियर, बिकॉज एज वी आर एडिंग द कॉलर हियर, इफ देयर इज ओनली सिंगल कॉलर, so you can say that the contact area is small here in this case, contact area is less, there is a less contact area because there is only single collar which is in contact with the bearing. But when we are using the two collars or three collars, so it means when we are adding the collars there, the contact area is also we are adding, the contact area between the wearing surface and the collar, that is go on increasing. So इस केस में क्या होगा, जो आपका एरिया ऑफ कांटेक्ट है वो इंक्रीज होगा, और जब आपका एरिया ऑफ कांटेक्ट इंक्रीज होगा तो क्या होगा, आपका फ्रिक्शन जो है वो ज्यादा होगा। मल्टी कॉलर के केस में क्या होगा, एरिया ऑफ कांटेक्ट आपका ज्यादा है। सो next actually I was taking this multi collar bearing, right, multi collar bearing. So as I discussed with you, in case of single collar bearing there is single collar there, right, and the load of the bearing, the load of the shaft, that is taken by the single collar. There is no direct contact with the bearing surface as well as the shaft surface. There is no direct contact there. So in this case, in case of single collar bearing, what happens that there is a contact between the collar and the bearing. So no direct contact there in case of single collar bearing. So you can say that the load is taken by the collar only. But in case of multi-collar bearing, what is multi-collar bearing? When there are two or more than two collars are there around the shaft, right? जो दो या दो से ज्यादा कॉलर जो हैं शाफ्ट के ऊपर होंगे, तो that type of bearing is called the multi-collar bearing. So there is no direct contact between the bearing surface and shaft surface. There is no direct contact there. So what is there? There is only the collars which are applied here in the shaft. That collar will take the weight because they rest on the bearing, and that they will take the load of the shaft here, right? So there is no contact in this case. What the main problem is there, when we are using the multi collars there, you can say that the contact area is more in that case as compared to the single collar bearing. So when the contact area is more, what happens? So when the contact area is more, it means there is the friction is more. So there is more friction there because the contact area is more there. So when the friction is more, you can say heat generation is more, and when the heat generation is more, then there is tear and wear and tear is more there. So this is about your multi-collar bearing. So next now you can say, so the bearings can also be divided on the base of lubrications. So next type you can say that bearing can be divided on the base of lubrications. So bearings can also be divided on the base of lubrications. ठीक है. So when there is thin film lubrication, right, so there are two types of lubrications there. तो पहले तो आपको ये फाइंड आउट करना है कि आपके पास कितनी टाइप की lubrications हैं. So there are two types of lubrications, that is, one is thin film lubrication and the second one is thick film lubrications, right? So the bearings, they are dividing as what the lubrication, what type of lubrications we are providing to the bearings and the journal there, right? So thin film lubrication, first I will explain what is thin film lubrication. Thin film lubrication क्या है और ये कहाँ पे किन बेयरिंग्स के लिए हम इस्तेमाल करते हैं, वेयर वी प्रोवाइडेड. सो फर्स्ट thin film lubrication. What is thin film lubrication? Try to understand it. Thin film lubrication, suppose here see your journal and this is your bearing, right? So this is your thin film lubrication. Here you will see there, so this is your this point of contact here, this is point of contact here, this is point of contact here, right? So in the thin film lubrication, when there is a very small layer of lubrication between the journal and bearing, when there is a very thin layer of lubrication between the journal and bearing, that lubrication is called the thin film lubrication, right? In this case, what is there? Still, you can say in thin film lubrication, there is a partial contact. There is a partial contact between the journal and bearings there. There is still partial contact there. They are not completely separated. Journal and bearing surfaces, these are not completely separated, but there is a partial contact there. Here you can say that there is, suppose this is your figure of the thin film lubrication. Here will you say that this is your point of contact. Here it is meeting here. This is the point of contact and this is the point of contact, right? So you can say in thin film lubrication, there is a partial contact between the journal and bearing, and this type of the lubrication is used where the speed is very low and the load is also very small. जहाँ पे speed इसकी कम होगी, जहाँ पे load जो है वो कम होगा, in that cases we use the thin film lubrication, right? Because there is metal to metal contact, still there is metal to metal contact there. What if we will use this type of lubrication in case of high speed, where there is high speed and high load? So what happens there? Still there is a contact here, metal to metal contact here. So here there is a great chances of producing the friction. So here the friction is more, wear and tear is more, and you can say heat generation is more. So ultimately what we do, we don't use this type of lubrication in your in the high speed, where the shaft is rotating very high speed, or you can say where load is very high, load is large. At that point we don't use this. So this is your thin film lubrication. Now we will take the what is thick film lubrication. In case of thick film lubrication, what is there? Thick film lubrication. So in the thick film lubrication, see journal and this is bearing. Here you will see in thick film lubrication, here you will see there is no contact between the metal to metal contact. There is no metal to metal contact here. So in thick film lubrication, the bearing surface and the surface of the shaft, that is completely separated. But in this case, there is partially separation of that and there is metal to metal contact also there. What in this case, the bearing surface and the journal surface, or you can say that the contact surface of the journal and contact surface of the bearing, that is completely separated, right? So that is completely separated in this case. There is no metal to metal contact here. This type of the lubrication that is used in very high speed, where the load is high, the speed is high. We use this type of lubrication, right? So this is all about your this thick film lubrication and the thin film lubrication, right? So in thin film lubrication, if I will give you the example, that is the example of the this hinge of the door. Hinge of the door, जो आपका door का hinge है, that is the example of this your this thin film lubrication. Here we will put 2, 3, 4 drops of the lubricant there. So that will act as a very thin film lubrication in that case. Here you will see the speed is very low, speed is very low and the load is also not very high there in that case. So that case we are using this thin film lubrication. What if we will come to this thick film lubrication? So thick film lubrication, you will say that is there is the complete separation of the journal surface and the bearing surface, or you can say the contact area between the journal and the bearing, that is completely filled with the high pressure lubricating oil which separates both the journal as well as the bearing, right? So in thick film lubrication, I think you understood this, what is thick film lubrication. So thick film lubrication, there are, this we have to see that in thick film lubrication how the pressure is generated. क्योंकि when the lubricating oil that is at the atmospheric pressure, this cannot take the load, right? So here you see that the surface of this bearing as well as the journal, that is completely separated. So it means the load on the journal, कौन सा लोड होगा जर्नल के ऊपर? वेट आपका जर्नल, उसका अपना वेट होगा, जो एक्सेसरीज हैं उसके ऊपर माउंटेड किया है उनका वेट होगा, that is completely separated. But when there is atmospheric pressure there, you can say this cannot be, ये हवा में जैसे आपको लग रहा है, this is separated, this cannot be possible. What it means that we have increased the pressure, we have created the pressure here. So with the pressure, that pressure will help to lift the base of the journal bearing, or that has taken the load of the journal and that has made it separated from the bearing surface. I think you understand. Now how the pressure is created, on that basis the bearing is divided into parts, that is hydrostatic bearing and hydrodynamic bearing, right? So so thick film lubrication में bearing is divided into part, that is hydrodynamic hydrostatic wearing, and second one is your this hydrodynamic wearing, right? अब ये hydrostatic wearing क्या है? How the pressure is created here? I told you there is the difference in the hydrostatic wearing and the hydrodynamic wearing is, what is the difference? That how the pressure is created between these two wearing, how it is created, how the pressure is created. In case of hydrostatic wearing, what is there? That we use the external source in this case, right? We use the external source, or you can say the pump we use there, and the high pressure lubricant is flowed inside the bearing. So you can say the pressure is created by the pump, external source there. So in this case, even the shaft is not rotating, even it is at the rest, still there is a thick film formation, and there is a thick film formation with high pressure. The thick film formation is there, right? In case of hydrostatic wearing, this is the way how the pressure is created, and this is the difference also. What in case of hydrodynamic wearing, as from the name you can understand that in case of hydrodynamic wearing means when the bearing is running with the full speed, when the bearing is running with the full operative speed or running speed, when it is running like this, when the shaft is rotating at a full operating speed, so what happens? Due to this, the pressure is created. The pressure is created between the bearing surface and the shaft surface, right? The pressure is created. So this is the way that how the pressure is created, and on that basis the bearing is divided. One is hydrostatic bearing and one is hydrodynamic bearing. तो हाइड्रोस्टैटिक बेयरिंग में मैंने बताया आपको कि इस केस में आपको क्या करना है कि एक्सटर्नल सोर्स से आपको प्रेशर जो है इसके बीच में आपने एक्सटर्नल सोर्स से प्रेशराइज्ड जो लुब्रिकेंट होगा यू हैव टू सप्लाई देयर, राइट? और अगर ये रोटेट भी नहीं कर रही है, इफ इट इज एट रेस्ट, यू कैन से इफ द शाफ्ट इज एट रेस्ट, इट इज नॉट रोटेटिंग, एट दैट टाइम स्टिल द थिक फिल्म इज फ्लोइंग बिटवीन द journal and the bearing, right? But in case of this hydrodynamic wearing, you have to, when the shaft is rotating at a very high speed, you can say at the operative speed, what is the operative speed? So you say suppose this is under 1000 rpm is the operative speed. When it is rotating at this speed, what happens that due to the converging of the wedge, जब ये इस स्पीड से रोटेट करेगा तो क्या होगा, एक वेज क्रिएट होगा, और वेज इसमें क्या होगा, उसका प्रेशर जो है वेज में प्रेशर उसका मैक्सिमम हो जाएगा, एंड दैट इज नॉर्मल टू द सरफेस. तो उससे जो आपका वेयरिंग है तो प्रेशर क्रिएट होने से उससे आपका जो वेयरिंग सरफेस है और जो आपका शाफ्ट का सरफेस है दैट इज नॉट इन कांटेक्ट, दैट इज कंप्लीटली सेपरेटेड, राइट? नाउ I will just explain you the hydrodynamic wearing. हाइड्रोस्टैटिक मैंने आपको बता दिया. हाइड्रोस्टैटिक वेयरिंग में what you have to do, आपको एक्सटर्नल सोर्स से प्रेशराइज्ड लुब्रिकेंट यू हैव टू सप्लाई इनसाइड, राइट? और इन केस ऑफ हाइड्रोडायनेमिक wearing there are three stages. One by one we will discuss that what is your initial stage, then how the load of the shaft is taken up. Second one is your when it is initially start, when it doesn't attain the maximum position at that time, what is the condition of the lubrication, and the third one is when it is running at the full speed, right? So I will discuss one by one. So first I will take this first case, right? In first case, what is there? I am just explaining the hydrodynamic bearing. First case is when the shaft is not rotating, you can say shaft is at the rest, right? So when shaft is at the rest, what happens? There is a metal to metal contact. There is a metal to metal contact of the shaft with the bearing surface, right? So in this case, as it is not rotating, so it means that the lubricant is not filling inside the shaft, inside this space. Lubricant is not filling because it is not rotating at all. So it is not filling there. So it means that the load which is acting on this shaft, the load, you can ask me that what is the load of the when it is not moving at all. So you can say it's the load of the shaft also there, and then the accessories which are mounted on that load is also there. So all this load that is acting downward like this. So you can say suppose the load is W into not W, load is W. So W is the load of this which is acting downward, right? So what happens there? To balance the load of this, there is a normal force which is acting in the upward direction, right? So this normal force will hold the load of the shaft here, right? This normal force will hold the load of the shaft here. This is the first case when the shaft is not rotating. When the shaft is not rotating, lubricant is not there because no pressure is created, lubricant is not there. In this case, there is metal to metal contact and the load of the shaft that is directly supported by the normal force which is acting in the upward direction. Now the case second. So in the case second, what is there? So in the case second, I am just trying to draw the handmade diagram, right? So in the case second, now just see here, this is your case second. This is your case second. This is your shaft, right? This is about to rotate now, right? This is about to rotate towards the clockwise direction. Now the shaft is rotating to the clockwise direction, but it has not attained the full operative speed initially, right? Initially it has not attained the full operative speed, because to attain the full operative speed it requires minimum sometimes, right? Suppose I say that bearing is designed for the 1000 rpm. So in this case, this will take few seconds to reach at the its full operative speeds. So during this period, if I say that period is 5 seconds or 7 seconds like this, during this speed, it is during this time, it is not such as a operative speed. तो इस केस में क्या होगा, जब ये रोटेट करना शुरू करेगा तो फ्लूइड जो इसके बीच में है, इसका जो आपका lubricant है, that starts filling up, right? Lubricant will start filling up, right? And it will climb on the right side of the, it will climb on the right side, right? जे right side के ऊपर climb करने की कोशिश करेगा, it will climb on the right side, right? So still there is partial contact. So in this case there is partial contact, you can say, right? So here you can say this is partial contact, आपका ये partial contact होगा. So this is partial contact in this case, right? क्योंकि it has not attained the full speed, it just starts to climb up and there is a partial contact here at this point. तो इस केस में how the load of the shaft is supported, how the load of the shaft being supported, किस तरीके से होगा. इसमें देखिए, इसमें तो था डायरेक्ट जो लोड था शाफ्ट का, दिस इज एक्टिंग डाउनवर्ड एंड दिस इज एक्टिंग अपवर्ड. सो इन दिस केस द लोड ऑफ द शाफ्ट दैट इज सपोर्टेड बाय द नॉर्मल फोर्स विच इज एक्टिंग इन द अपवर्ड डायरेक्शन. तो इस केस में क्या होगा, तो ये आपका नॉर्मल फोर्स एक्ट करेगा. सो दिस इज योर नॉर्मल फोर्स, राइट. अब मुझे बताइए, व्हेन इट स्टार्ट्स रोटेटिंग and there is still metal to metal contact, it is not fully separated, so it means that there is a frictional force also. Which force is acting now? There is friction force also. So as it is rotating in the clockwise direction, so definitely friction force will act in the anti-clockwise direction, right? तो friction force क्या करेगा, anti-clockwise direction की तरफ rotate करेगा. So frictional force is like this. This is your frictional force. This is your frictional force mu n, right? Mu n is the frictional force which is acting towards the anti-clockwise direction, right? Now, if I will take the resultant of this, so definitely this load has to be supported by some force. So that force which is the resultant of this normal force as well as the frictional force, the resultant will act like this. So this is your resultant force. So here you have seen that in this case, when it is about to start, when it just start rotating, this is the second case when the shaft just start rotating, right? It has not attained the complete operative speed. Within that period, from 0 to operative speed, within that period of time, so what happens? It is not in the full operative speed. In this case, just the lubricant, it starts climbing towards the right side. It has not completely formed the thick film lubrication here, but it just start to climb here. तो ये right side के ऊपर climb करेगा, उससे क्या होगा, still there is a partial contact between the journal and bearing in this case. तो जो partial contact होगा, suppose the partial contact is at this point. Now in this case, how the load of the shaft is supported? इस केस में तो नॉर्मल फोर्स से इसका लोड जो था इसने सपोर्ट किया. इसमें किस तरीके से होगा, इसमें देखिए जो नॉर्मल फोर्स है, दिस इज एक्टिंग अपवर्ड डायरेक्शन बिकॉज द वेट इज एक्टिंग, द लोड इज एक्टिंग डाउनवर्ड डायरेक्शन, तो नॉर्मल फोर्स इज एक्टिंग अपवर्ड डायरेक्शन. नाउ बिकॉज इट हैज जस्ट स्टार्ट रोटेटिंग, it is rotating and there is metal to metal contact there, it means there will frictional force will develop, right? सो फ्रिक्शनल फोर्स जो है जहां पे डेवलप होगा, एज इट इज रोटेटिंग इन द क्लॉकवाइज डायरेक्शन, यू नो द डायरेक्शन ऑफ द फ्रिक्शनल फोर्स दैट इज अपोजिट टू द रोटेशन ऑफ द शाफ्ट। तो इसकी जो अपोजिशन क्या होगी, रोटेशन ऑफ द शाफ्ट, दिस इज द अपोजिशन ऑफ द रोटेशन ऑफ द, सो द फ्रिक्शनल फोर्स म्यू will act like this, right? So the resultant of the normal force and the frictional force, that is resultant force which is acting upward because its direction is upward because it has to supporting the load here. So that resultant of the normal force and the frictional force, that resultant force will support the load. तो second case में क्या होगा, जो रिजल्टेंट फोर्स इन दोनों के बीच में एक्ट करेगी वो लोड को सपोर्ट करेगी। अब आ जाएंगे हम थर्ड केस में, व्हेन इट इज ऑपरेटिंग एट फुल स्पीड, सो दैट इज केस नंबर थर्ड। So here you will see, this is the final case, that is the case number third. This is the final case of this. So here in case number second, I have explained you that the shaft is just start rotating. It has not attained its full operating speed, right? So at this time, the load of the shaft, that is supported by the resultant force, which is acting upward direction, resultant of the normal force, whereas frictional force. Now come to this case number third. So in case number third, you have seen that here the shaft is operating or rotating at the full operating speed. Now it has attained the full operating speed, right? So when the shaft is operating at the full operating speed, what happens? The pressure will created due to the high speed of the shaft. So if I will give you the example of this, suppose this is your as the fluid is flowing through the converging portion, Suppose some fluid is flowing through the converging portion. What happens there? When it will reach to this point, this is the converging section of the fluid. What happens there? The pressure will be created, and pressure is perpendicular to the surface of the fluid. Right? So in this case, when it is rotating with a high speed, what happens here? That this side, जहां तो कोई प्रॉब्लम नहीं है फिल्म का, जहां फिल्म जो है आपका डाइवर्जिंग है, बट जहां पे जो फिल्म है ये आपका जहां पे क्या होगा, कन्वर्ज होना शुरू हो जाएगा. दैट विल वेज इज क्रिएटेड हियर. और जो वेज जहां पे क्रिएट होगा एंड इट इज मूविंग विद ए वेरी हाई स्पीड, सो व्हाट हैपेंस, द प्रेशर इज क्रिएटेड हियर. प्रेशर ऑन द लुब्रिकेंट इज क्रिएटेड. सो प्रेशर जो इतना हाई प्रेशर होगा लुब्रिकेंट का इस स्पीड इस पॉइंट के ऊपर, that the wearing surface as well as the shaft surface, that is not in contact to each other, that is completely separated due to the high pressure which is created due to the bed, because it is narrowing down here, there is a converging here. So when there is a conversion of there, what happens, that the bed will be created, and in that wedge the high pressure will be developed. So this high pressure will separate the shaft and the bearing surface, right? So this is the three methods, this is the three way. First case is when your shaft is at rest. So what happens there when the shaft is at rest? So there is metal to metal contact here, and the load of the shaft, that is supported by the normal force. In this case, when it is just start rotating, in that case the full speed is not attained by it. So there is still metal to metal contact, there is a partial contact, but still there is a metal to metal contact. In this case, because as it is rotating also, in this case one normal force will be there and one frictional force will develop, which is opposite to the direction of the rotation. तो ये जो फ्रिक्शनल फोर्स होगी इसकी रोटेशन के अपोजिट डायरेक्शन में होगी, तो इन दोनों का जो रिजल्टेंट होगा दैट विल सपोर्ट द लोड हियर. बट इन दिस केस द हाउ द लोड इज सपोर्टेड, ये आप देख रहे हैं कि शाफ्ट और इसके बीच में देयर इज ए स्पेस हियर, राइट. इट इज नॉट रेस्टिंग ऑन द wearing surface. The surface of the shaft is not resting on the wearing surface. तो जैसे मैंने आपको बताया कि जो कन्वर्ज पोर्शन होगा, अगर जहां से फ्लूइड आपका पास करता है, एंड व्हेन इट विल गो टू द कन्वर्ज पोर्शन, व्हाट हैपेंस, देयर इज ए प्रेशर व्हिच इज एक्टिंग नॉर्मल टू द फ्लूइड, राइट. तो ऐसे ही दिस इज योर बैच एंड हियर द प्रेशर इज क्रिएटेड, राइट. So here the pressure is created. What happens? So this pressure will, this is normal, this pressure will support the load of the journal, right. So this pressure will support the load of the journal. So this is about your hydrodynamic bearing, that how it will function, how the lubricant here is compressed, and what are the base, what are the three stages here. This I told you, stage number 1, केस नंबर 1, उसमें क्या है, किस तरीके से इसका लोड सपोर्ट होगा. जब केस नंबर 2 आएगा, जब ये जस्ट स्टार्ट करेगा रोटेशन का, तो उस वक्त इसकी किस तरीके से पोजीशन होगी. देयर इज ए पार्शियल कांटेक्ट बिटवीन द जर्नल एंड बियरिंग सरफेस, एंड द लोड इज सपोर्टेड बाय द नॉर्मल, लोड इज सपोर्टेड बाय द रिजल्टेंट ऑफ द नॉर्मल एंड एज वेल एज द फ्रिक्शन फोर्स. बट इन केस थर्ड, व्हेन इट इज ऑपरेटिंग एट ए हाई फुल स्पीड, when it is operating at a high full speed, the film start pressurized here, and there is the, as it is rotating the clockwise direction, so at this point there is a creation of the wedge here, and due to the creation of the wedge, what happens here, some pressure is created in the thick film lubrication or you can say thick film lubricating oil, the pressure is created and pressure is the normal to the surface. So the load of the journal is being supported by the pressure which is created in the upward direction. So this is about your hydrodynamic bearings. अब small जो इसका एक portion रहता है, that will also I will explain you. You can say characteristics of bearing characteristics of bearing material. ठीक है, तो इसको भी थोड़ा सा मैं आपको बता देता हूं कि जो आप बेयरिंग मटेरियल इस्तेमाल करते हैं, यूज करते हैं, उसकी क्या क्या कैरेक्टरिस्टिक्स होनी चाहिए. ऑन दैट बेसिस यू हैव टू सिलेक्ट इट, राइट. तो पहला कैरेक्टरिस्टिक्स हम कह सकते हैं कंप्रेसिव स्ट्रेंथ. कंप्रेसिव स्ट्रेंथ. So I will explain this. Bearing material should have high compressive strength. जो bearing material हम select करेंगे, जो bearing material होगा उसकी जो compressive strength है that should be high, so that it can withstand the high pressure without distortion, right? Compressive strength किसके लिए चाहिए? It can withstand high pressure without distortion. कि हाई प्रेशर को ये विथस्टैंड कर सके. ये फर्स्ट प्रॉपर्टी है इसकी बेयरिंग मटेरियल की. सेकंड, सपोज आप लेते हैं फटीग स्ट्रेंथ. तो इसमें बेयरिंग मटेरियल शुड हैव, इस केस में भी हाई आपकी फटीग स्ट्रेंथ होनी चाहिए मटेरियल की, सो दैट इट विल विथस्टैंड द रिपीटेड लोड एंड इट कैन विथस्टैंड द फटीग ऑफ दैट. ठीक है ना. जो रिपीटेड लोड जो इसके ऊपर हम अप्लाई करेंगे उसका जो फटीग पैदा होगा, उससे जो फटीग होगा उसको ये विथस्टैंड कर सके, राइट. ये सेकंड है फटीग स्ट्रेंथ, राइट. अब थर्ड है कंफर्टेबिलिटी. थर्ड क्या है? कंफर्टेबिलिटी. कंफर्टेबिलिटी क्या है? दिस इज द प्रॉपर्टी ऑफ द मटेरियल which can adjust the deformation, right? क्योंकि in case of this I told you that the axis of the bearing and the axis of the shaft, that is eccentric, right? That is eccentric. So there is a misalignment also, or you can say there is not 100% perfect alignment in that case. तो उस केस में जो अलाइनमेंट मिस अलाइनमेंट के केस में जो डिफ्लेक्शन या डिफॉर्मेशन होगी, तो इस मटेरियल की ये प्रॉपर्टी होनी चाहिए कि उस जो आपका डिफॉर्मेशन है उसको ये विथस्टैंड कर सके, उसको ये एडजस्ट कर सके. सो दिस इज अबाउट योर कंफर्टेबिलिटी क्या है. फिर इसमें फोर्थ आता है एम्बेडेबिलिटी. ये क्या चीज है? एम्बेडेबिलिटी क्या चीज है? एम्बेडेबिलिटी, दिस इज द कैरेक्टरिस्टिक्स ऑफ द bearing material which can embed the dust particles or any foreign particles. ये अपने सरफेस में उसको ये एम्बेड कर सके, अपने सरफेस में उसको ये स्टिक कर सके, so that the surface of the journal or the surface of the shaft that is not affected at all. There is no scratch on that. There is no wear and tear on that. So this property you can say embeddability means that will embed the dust particles or any other foreign particles which are there. The bearing material should be like this, that will embed these particles in itself, so that the journal or the shaft which is rotating at a very high speed, that is not affected by the dust particles or the foreign particles, and it will not give any damage or scratch to the shaft, right? So this is your embeddability. Now next one you can say thermal conductivity. थर्मल कंडक्टिविटी क्या है? व्हाट इज दिस? थर्मल कंडक्टिविटी, द मटेरियल, जो बेयरिंग मटेरियल लिखा है, इसका एक ये भी कैरेक्टरिस्टिक्स होनी चाहिए, इट शुड हैव हाई थर्मल कंडक्टिविटी. इसकी हाई थर्मल कंडक्टिविटी होनी चाहिए, सो दैट इट कैन रिलीज द हीट विच इज जनरेटेड ड्यूरिंग द कोर्स ऑफ during the course of moving the shaft, rotating the shaft. जो उसमें हीट जनरेशन आपकी होगी ड्यू टू द फ्रिक्शन और ड्यू टू द अदर फैक्टर्स आल्सो, जो हीट जनरेशन होगी, ये जो बेयरिंग मटेरियल है उसका ये कैरेक्टरिस्टिक्स होनी चाहिए कि उसकी थर्मल कंडक्टिविटी ज़्यादा हो, सो दैट इट कैन रिलीज दैट हीट क्विकली और इट कैन डिसिपेट द हीट वेरी क्विकली. सो दिस इज वेरी इंपॉर्टेंट. One of the property or the characteristics of the bearing material is thermal conductivity should be high, right? Now suppose next one is, I will say one more is there, thermal expansion. So thermal expansion क्या है? This is also the one very basic characteristics of the bearing material. Thermal expansion means it is having a low thermal expansion. इसका thermal expansion जो भी characteristic है, that should be a low, so that due to heat generation there is no deformation, there is no expansion of the material, so that the gap between the wearing surface and journal surface that will be minimized. तो थर्मल एक्सपेंशन इसका लो होना चाहिए, सो दैट कि उससे आपका जो एक्सपेंशन है वो कम से कम हो ड्यू टू द हीट जनरेशन, राइट? सो दीज आर फ्यू सम कैरेक्टरिस्टिक्स विच आई हैव डिस्क्राइब्ड यू. दैट इज कंप्रेसिव स्ट्रेंथ इसकी ज्यादा होनी चाहिए, सो दैट इट कैन विथस्टैंड द हाई प्रेशर. फटीग स्ट्रेंथ इसका होना चाहिए, so that it will withstand the repeated load, और उससे जो fatigue का फॉर्मेशन होगा that it can withstand that. कंफर्टेबिलिटी का मैंने आपको बताया. कंफर्टेबिलिटी क्या है कि जो एडजस्ट करने की इसका है, due to the deflection, due to the misalignment, there is a small deflection there. So this bearing characteristics, material characteristics should be like this, that will adjust the small deflection or deformation, right? तो ये कंफर्टेबिलिटी इसका है। एम्बेडेबिलिटी का मैंने जैसे आपको बताया, एम्बेडेबिलिटी का मतलब क्या है कि wearing material that should attract the dust or embed the dust particles or any foreign particles in its own material, so that will not affect the shaft, that will not damage the shaft, that will not give any scratch to the shaft. So this is also very important, one of the characteristics of the bearing material. And the next one is your thermal conductivity. मैंने आपको बताया what is thermal conductivity. Thermal conductivity क्या होता है? Thermal conductivity means its ability, or you can say it is having a high thermal conductivity, so that it will release or it will dissipate the heat as quickly as possible. So this is also one of them. And the thermal expansion, which I told you, it is having a less thermal expansion, so that it will not deform at all, it will not expand at all due to the heat generation or any other factor, right? So this is all about today, up to this characteristics of the bearing material. Now the next lecture, which I will take tomorrow morning, that in that lecture I will give you the parameter of the design, parameters इसमें क्या क्या होंगे, और उसके बाद I will go for the design of the journal bearing. Okay, thank you very much. And I think this lecture is very, very productive for you, because I have just completed each and every thing of the theory part complete. I did not leave anything. Whatever is there regarding to the bearing, whether it is in your ESC exam or GATE exam, I have given you the complete description of each and everything. And tomorrow, now I will go for the design part of this. Thank you very much. Thank you.